Hello everyone, let's start by going over our practice from yesterday's lesson, our lesson on transforming. So what we're talking about here is we're looking at this distribution and it has a random variable x with a mean of 1.1 and a standard deviation of 0.943. Okay, and what we need to remember is that X is the number of cars sold during the first hour of business on a randomly selected Friday. So let's keep in mind that that is the first random variable that we're looking at right here. For number one, it says sketch a graph of the probability distribution of X. We did that right here. Okay, and then it says suppose the dealership's manager receives a $500 bonus from the company for each car sold, and why is the bonus received from car sales during the first hour on a randomly selected Friday? So what we're doing here is we're adding, we're multiplying by $500. So one car times $500 is 500. 0 cars times 500 is 0. 2 times 500 is 1,000. So we're multiplying here. We saw above in our notes that when you multiply, the shape stays the same, and this proved that. Down here it says find the mean of the new random variable y. Well, what we're doing is we're taking the mean of random variable x and we're multiplying it by 500. When we multiply by a constant, we multiply every single term by a constant. We multiply the mean by that constant also, so the mean is 550. And the standard deviation also gets multiplied by that particular constant. So the standard deviation of x is 0.943. We multiply by 500, it's 471.5. The interpretation is the bonuses typically vary by $471.50 from the mean of 550. The manager spends $75 to provide coffee and donuts to prospective customers each morning. So the manager's net profit, random variable t, during the first hour on a randomly selected Friday is $75 less. So now we're subtracting $75 from mu sub y. The shape is going to stay the same. It's still going to be right skewed, just like y is up here. The center is going to move down by the value we're subtracting, so we're going to subtract down 75. The mean of random variable t is 475, and the standard deviation is not going to change when we do subtraction, okay? So hopefully you checked that, and now we'll get started on the new lesson. All right, so let's get started. We're talking about combining random variables. It says, how much will you make next year? So after a lot of thought, I finally decided on a permanent employee wage, which are randomly assigned using the probability distribution X, which is given below right here. Additionally, at the end of every year, she gives her employees hourly raises. The bonuses are assigned randomly according to the probability distribution Y, which is given below here. Assume X and Y are independent variables. Here it says find the mean, variance, and standard deviation of the probability distribution of X, which is the hourly wages. Remember, how you do this is you're going to put X into list 1, the probabilities into list 2. You're going to run the one variable stats on list 1 with the frequency list of list 2. You should get out a mean value of 11.85 and a standard deviation, which is sigma sub x of 2.22. Remember, your variance is your standard deviation squared, so the variance is 2.22 to the second power, which is approximately 4.93. You want to make sure that you know how to get these on your own. Same thing down here, you're going to put y into list 1, the probability into list 2, and run the one variable stats. You're going to get a mean of 1.60, a standard deviation of 0.917, and the variance is the standard deviation squared, and we can get 0.840, okay? So now we're introducing a new random variable, which is the new hourly wage for the upcoming year. So that is my current hourly wage plus the raise that I'm getting. So what we're doing is we are now adding together two random variables. What are all possible new hourly wages for the new year? So you can look above in the table. I can start off with $9 and then get a $1 raise, so I could have $10. I could start off with $12 and get a $1 raise, which would be 13, or 15 with a $1 raise would be 16. I could start off with $12 and get a $3 raise, which would be $15. I could start off with $15 and I could get a $3 raise, which is $18. Oh, and also I could start off with $9 and get a $3 raise, which would be $12. So those are all the possible new hourly wages that we could get. What is the probability of an employee being assigned a $9 wage and a $1 raise? Okay, since these are two random variables, we're just looking at the probability of a $9 wage and the probability of a $1 raise. The probability of a $9 wage is 0.3, and the probability of a $1 raise is 0.7, which is 0.21. Because these are two independent events we learned from last unit, you can just multiply those probabilities together. Complete the table below for the probability distribution of x plus y. So now I'm looking at random variable n, and I have these options. Let's put them in number order. I've got 10, 12, 13, 15, 16, and 18. So the probability of $10 is a $9 wage and a $1 raise, which would be 0.21. $12 is a $9 wage and a $3 raise, which is 0.09. And I'm going to give you guys a second to just complete this table as follows. As soon as you complete the table, take a second to find the mean, variance, and standard deviation using your calculator. If you need to, pause the video, do the work, and see if you got it correct. So after you calculate the new mean, variance, and standard deviation, we can see what happens when we're adding or combining two random variables to get a third random variable. You should see that mu sub n is really just equal to mu sub x plus mu sub y. You can see that if you were to just add these together, you would get your new mean. Okay, and sigma sub n might be a little bit more tricky for you to notice, but it's this variance of the x variable plus the variance of the y variable added together, and then we take the square root. So instead of making this distribution every single time and putting it in our calculator and calculating that, we do have a formula where I can just take the variance plus this variance here plus the variance here, and then take the square root, and I will get this, take the square root, I'll get the standard deviation. No square root, I'll just get this variance. Okay? So on the back page, we kind of saw a linear combination in action. Let's get down some formal definitions now. A linear combination is when a random variable is connected to a combination or function of other random variables. Okay, so for example, we could have one random variable, y, be dependent on another variable, x. This would be an example of one variable. Or we could have more than one variable. I could have random variable y dependent on two variables, like 2x plus 3z. Depending on the context, you could have multiple variables. The mean of the linear combination, how does this work? So mu sub y, if y is a linear combination, how do you find it? You plug in all mean values into the function or combination. This might seem kind of weird right now, but when we do some examples, it'll make a little bit more sense. And the standard deviation, or the variance of a linear combination, is a formula also. So the standard deviation is sigma squared sub y. And what we do is we take the leading coefficient of the combination, we square it, multiply that by the associated standard deviation squared, or the variance, and we add that for each part of the combination. Okay, where A is a coefficient and remember you take the square root to get the standard deviation, which is sigma sub y. For your normal probability distribution, be sure to find the new mean and standard deviation before you start working on it. All right, although we saw some of that in action on the last page, that was a pretty simple linear combination because it was just x plus y. We didn't even have any coefficients. So let's look at something maybe a little bit more complicated in the next, not the one below, but upcoming. This next example you can do on your own. So if I were you, what I recommend is you pause the video, complete the U-try, and then when you're ready, unpause and check your answers. All right, let's take a look at this example. So X is the number of cars sold and Y is the number of cars leased during the first hours of business on a randomly selected Friday. We've got some stats. The mu sub X, the average of the number of cars sold, is 1.1. The standard deviation, sigma sub X, is 0.943. The mean of the number of cars leased is mu sub Y, that's equal to 0.7. The standard deviation, sigma sub Y, equals 0.64. It says right here, find and interpret mu sub t. T is defined as x plus y, okay? That's going to be the total numbers of cars sold and leased. So just like we said above, up here, it said to find the average, you're going to plug in all mean values to the linear function or combination. And down here, I'm seeing, okay, to find mu sub t, I'm going to plug in the associated x mean, that's 1.1, plus y, I'm going to plug in the associated y mean, which is 0.7, for the new mean of 1.8. So over many Fridays, the dealer expects to sell and lease on average about 1.8 cars. Calculate and interpret the standard deviation. The standard deviation, we have a formula. Remember, it's a sub 1 squared times sigma sub 1 squared plus a sub 2 squared times sigma sub 2 squared. Okay, so you can see that we followed that formula. The leading coefficient is 1, so that's why I have the 1 squared here, just so that you can see that we still square that coefficient, but it doesn't really make a difference. And then we multiply the associated standard deviation, we square that, plus the leading coefficient of the y is 1 squared times that associated standard deviation, which is 0.64 squared. And then we take the square root to get the standard deviation rather than the variance, and it's 1.14. The interpretation is number of cars leased typically varies by 1.14 from the mean of 1.8 cars. The dealership's manager receives a $500 bonus for each car sold and a $300 bonus for each car leased. Find the mean and standard deviation of the manager's total bonus. So random variable B is $500 per car plus $300 per car sold plus car leased. So again, just like above, to find the average, we plug in the mean values where they belong. So to find the average of B, we take 500 and we multiply it by the associated X value average, which is 1.1, plus 300 times Y's associated average, which is 0.7, and we get a mean of 760. The standard deviation, again, same formula. It's the leading coefficient. This time it's 500 squared times the associated variance or standard deviation squared, which is 0.943 squared. Then we add the next term, that leading coefficient squared times its associated standard deviation, which is 0.64 squared. And we work that out to get a standard deviation of 509.09. On this page, we have some practice problems. Let's go ahead and go through the first one together, and then you can do the second one on your own. Let X represent the cubic feet of a fridge. The fridge has a base price of $300 and increases $200 with each cubic foot. The mean cubic footage of a fridge is 5 cubic feet with a standard deviation of 0.5 cubic feet. How many variables is this linear combination based off of? And the answer here is 1. Okay, price, which is Y, is based off of X, which is the number of cubic feet. Okay, so one variable, and that is X equals number of cubic feet. Could you name it anything you want? Sure, I named it X. Okay, write the linear combination for the random variable. This should be Y, not X, my apologies. Y equals, the price is equal to $200 for each cubic foot plus a base price of $300. And Y is the total cost of the new fridge, right, or price. Find mu sub Y. Okay, well, mu sub Y means I'm going to use this formula, my linear combination, and everywhere I see X, I'm going to plug in the X average. Okay, let me go see if I have that. Actually, I do, because it tells me the mean cubic footage of a fridge is 5 cubic feet. That is the mean of variable X, and the standard deviation of variable X is 0.5. So we'll have 200 times 5 plus 300. So mu sub Y is 1,300. In context, this means the average price or the expected value of a fridge is $1,300 if we look at many different fridges. Find the variance and the standard deviation. All right, sigma squared sub Y is equal to the leading coefficient, which is 200, squared, times the standard deviation associated with that variable. This is variable X. The standard deviation is 0.5, so it's 0.5 squared. One thing, you leave out constants. Constants are constant. They are not changing the spread, okay? So we're gonna leave that out right here. The variance is equal to 40,000 times 0.25, which is 10,000. And to find the standard deviation of Y, we take the square root of that, which is $100. So price typically varies from the mean of $1,300 by $100. All right. Why don't you pause this video, take a second to try example 2 on your own, then unpause and see if you got it correct. All right, let's read this example. So it says we're going to a farmer's market and collecting apples and pears in a bag to buy. The farmer's market charges by weight per pound. The average weight of an apple is 80 grams with standard deviation 6. The average weight of a sugar pear is 60 grams with standard deviation 4. So to find your variables, A is the weight of an apple and P should have been defined as the weight of a pear. The average of the weight of the apples is 80 grams. The standard deviation of the weight of the apples is 6. The average of the weight of the pears is 60, and the standard deviation of the weight of the pears is 4. We want to buy 5 apples and 7 pears. W is the weight of the bag, the total weight. And the linear function is the total weight is equal to 5 times the average weight of the apples plus 7 times the average weight of the pears. The average weight of the bag is going to be 5 times, instead of A, we plug in the associated mean, which is 80 grams, plus 7 times P, we plug in the associated mean, which is 60 grams. That's 820 grams total. For the standard deviation and variance, we follow the formula, which is leading coefficient squared times the associated standard deviation squared plus next leading coefficient squared times associated standard deviation squared. The variance is 1,684. The standard deviation is the square root of that, which is 41.04 grams. Okay. All right. Thank you so much. Make sure you complete your quiz review, and I will see you later.